I was really surprised by this music. Um, okay, so unfortunately you can't see my cool stickers on my notebook, but yeah, what's the topic is? I'm joking. Okay, so today I'm gonna tell you some cool stuff about blockchains, about open source related with blockchains. And first of all, please raise your hand who doesn't know what the blockchain is. Okay, that's good. Thanks God. Because sometimes I always have to start off explaining what's the blockchain and so on, and you know. Okay, let's start. Today I'm going to tell you about framework called Exonum, which is the framework for private blockchains. But first of all, let me introduce my company that I work for, Bitfury. We are spreading global blockchain technology around the world. Started from mining and creation of tech for mining. And now we are also involved in lots of projects, software projects based on blockchain technology. Let's talk about some traditional architecture of web apps. Very often they are quite messy, so we have some servers, we have some cloud services like Azure or AWS, and one of the most dangerous and not cool things that we have an administrator who's basically the king of all this mess. And why is it a danger? Because administrator may change anything, and the administrator may lose some data by accident because he's a human being. And also, we as a customer should trust this administrator absolutely. So here's the blockchain comes. Yeah, this guy will help. Okay, I'm not gonna tell you deep about public and private blockchains, and I think everyone understands that the advantage of public blockchain is high level of security, and the disadvantage is speed, right? Because it's quite slow sometimes. As private blockchains, they are oppositely they are speedy, but the level of security is classically low, but there are some ways to increase this level. So basic architecture of web application that uses blockchain looks like that. So we have nodes. They interact with each other through consensus algorithm. And you as a client or some client code, whatever, you interact with nodes and get some information, put some information on the blockchain, etc. Let's talk about our open source framework, which is called Exonum. And I also wanted to tell you about some cool features that we have. First of all, this is an open source platform, and everyone knows what it means for market. And also, this is just the framework, so we don't have any built-in logic, any cryptocurrencies or UTXOs or something like that. So you may build your own business logic, depends on your needs. We also have a smart contracts feature. We call them services, but basically this is a business logic stuff that you can put inside of the framework. Also, we have lots of cool things in the open source. So we have documentation, we have some services that may help you with different business cases. Also, we provide testing tools and so on. So, what about the language that our framework written in. It's Rust. Rust is a very secured language in terms of memory usage and concurrency operations. It's also quite speedy because it's very similar to C++, and in comparison with Java or some high-level languages, it's quite speedy. What about consensus? We use BFT-based consensus algorithm. You may go to our website and go through some deep articles with theorems and all the stuff that proves this algorithm. Because of this consensus algorithm, we have pretty good speed. We are processing around 5,000 transactions per second, and we have 0.5 latency of blocks generation. As for security inside of blockchain network for message sharing, we use digital signature based on elliptic curves ED25519 and also classic SHA256. Anchoring, which is, I would say, one of the coolest features of our approach. How it works? Architecturally, it's very similar to a sidechain concept. Periodically, we take a snapshot of our private network and publish it on the Bitcoin, which increase a level of resistancy to collisions. Also increase the level of security because of blockchain as a public, because of Bitcoin as a public blockchain, right? And if you want to rewrite some piece of our private blockchain, you need to rewrite Bitcoin first. So good luck. Okay, one more cool feature is the light client. It's basically it's a JS JavaScript library, also open sourced, which helps you with transaction creation. Also, it helps to serialize these transactions to JSON format, signs transactions with digital signature, and sends to the blockchain network. Also, you may use light client for checking of cryptographic proofs. And about our cryptographic proofs, we inside of our data storage, we use Merkleized trees as a structure for data that we store, and it helps to describe cryptographic proofs so that anyone could prove that some piece of data stored on the blockchain and not in some black box, for example, because this is all about math and strict calculations. Okay, so as for the comparison of public and private blockchains, now we see that Exonum has advantages of public and private ones. So we have security because of privacy and because this blockchain system is based on BFT Consensus, which is speedy, and we don't need thousands of participants. And we also have security because of anchoring mechanism that gives us an opportunity to publish some critical information on the Bitcoin network. So in the third part of my speech, I'd like to tell you about Exonum for developers. Which user roles do we have for our system? First type is maintainers. Second type are auditors and clients. First of all, in our Bitcoin network, blockchain network, sorry, we use two types of nodes. First type is nodes validators. These guys take active part in consensus algorithm, and they give you an opportunity to provide transactions or some other changes to blockchain network. Also business logic as well. Second type of nodes are auditors, and they have the whole copy. They are the real copy of the blockchain network, and they give you an opportunity to audit information, but they don't have permits to suggest transactions or some other changes. So as for maintainers, they have rights to read, and they also have permits to write, if we are talking in terms of some programming structures. Auditors, they only have right to read information and to provide audit, and don't have permissions to write or change something. Clients, they basically don't interact with blockchain network directly. They do it through some websites or some client's application, etc. And all of our users, they may use cryptographic proofs so that each piece of data that's stored on the blockchain could be added with the cryptographic proof, and every time we could prove basically that the information stored on the blockchain. Well, as for some examples in different fields, let's talk about financial ledger. And in a role of maintainers, we may get banks or some exchange platforms that wants to provide service based on blockchain technology. As an auditors for this field, we may get some government organizations that control banks and exchanges. And as a client, we are getting bank clients who use banks' systems, banks' websites, and so on. Also, let's talk about a field of public registry. As a maintainer, we may take some government organizations, for example, some land titling systems that want to store some data, some critical data on the blockchain. As an auditors, we have some third-party organizations like Transparency International or World Bank that have to audit data stored on the blockchain. As for clients, it's simple also. It's just citizens that have some rights, that have some ownerships, and they have to store this information somewhere securely. Okay, so what are the parts of typical web application based on Exonum? So we have a classic front-end and back-end parts. As a back-end part, we have a blockchain network with the corresponding service, which consists of business logic you need to provide. As a front-end, we may use our JavaScript library built in some website or some other client's code. And it works like light client should create a transaction, serialize this transaction to the JSON format. After that, it signs it with the digital signature and sends to the backend. After that, backend takes the transaction, verifies this transaction, checks the digital signature for security, and applies it as it is. Also, backend may respond with some information, for example, transaction ID or some piece of data with cryptographic proof. It depends on business logic as well. Okay, so what do we need to create a classic service on Exonum? First of all, you need to identify which data you want to store and what's the relations between these entities you're gonna provide. So you need to understand which data schema you want to use. in terms of relations, foreign keys, and all that stuff. After that, you have to define a set of transactions that gonna change information on the blockchain. And the third step and the final one is to identify an API for the end clients. It also depends on needs of this client, so which data and which sizes he wants to get from the blockchain. Okay, so we have several useful services in the open source. First of them is a time oracle. I think that you are familiar with the problem of time in blockchains, time of block acceptance. And this service helps with that a lot. Also, we have a service of anchoring in the open source. I've been telling about that a couple of slides ago. And the third one is the configuration service, which helps to change settings of blockchain network or configuration of blockchain network on fly, which is also very useful sometimes. So as for the time oracle, how it basically works. Each Exonum validator has its own source of time, and the corresponding service works on this node, validator node. And once in a block, it forms a transaction with the corresponding time and sends it to the network. And when the transaction with this corresponding time is executed, we may calculate a direct time of block and kind of fix this big problem with time. So how it looks on the schema, we have external data, in our case, external sources of time. After that, nodes with corresponding services gather this data, each from its own data source. And after transactions executed, we have a general status of time that goes to corresponding block as a timestamp. Okay, as for the configuration service, that is also in the open source, how it works. For example, if you need to add one more participant into your private blockchain network, you need to take your current configuration from this service, add some changes, for example, public keys of corresponding new participant, or if you want to remove some participant, for example, because we don't have enough trust for this node, right? After you have created a proposal, other participants have to vote for this proposal, positive or negative way, depends on your proposal, basically. And in case if we are getting 2/3 + 1 positive votes, this configuration will take place from corresponding height or block number. And we're going to have a new configuration, and some participants will be added or removed. Well, this is basically all I wanted to tell you about our framework. Thanks for your attention. Let's go to questions, I think.
Thanks, Dmitry.
Yeah.
Actually, we do have a couple of interesting questions. The first one that comes to mind, whenever we're creating these services on Exonum, where are they stored exactly? Where is the Exonum app stored?
Okay, it's stored on servers that you provide for the network. So it can be AWS, or it can be some data centers around the world. So they should be spreaded, and more nodes is better, because this is about blockchain and consensus and so on.
Yeah, I guess, and then another related question would be then, can you give some details on the snapshot that is sent to Bitcoin?
Yeah, sure. So it Basically, this is a hash of corresponding block. For example, we may take a hash of each 10th block, or take a hash of block once per hour or once per day. And all we need to do is to publish this hash on the Bitcoin network. And that will give us a point of anchor, basically. That's why it's called anchoring. And we will know from which point we're gonna restore private blockchain network in case of some corruptions or majority corruption, which is also always possible.
Okay. So maybe this question would be more in line with what you just answered. I want to come back to the Hyperledger question. Is it possible to have blockchain forks?
Well, basically, this is a library. We are working on a library, and it's open sourced. You have to take this library and put your business logic, and you don't need to fork something like in case of Ethereum, for example, which or Bitcoin.
Okay.
You have to take a library and provide your own logic. It may be something similar to Ethereum or some kind of crypto currency. And after that, from your repository that owns your business logic, someone may take some forks. Why not?
Okay. So then a good question would be, actually, what is the difference between your service, Exonum, and Hyperledger Composer?
Okay. As for Hyperledger, comparing, we are a little bit speedy. I know that Hyperledger also has enough speed of transaction processing, but we have 5,000. They have around 3 or 3.5, I guess. Also, we have anchoring, which is gives us an opportunities of public blockchains. We use Rust, which is the quite secured language, and if we want to build a secure database, which is in general blockchain is, we have to use a secured language, and this is quite some silver bullets.
Okay. So we have time for these last two questions.
Okay.
So back to, you were talking about anchoring. Is anchoring a bottleneck on performance with Exonum, as it is done outside the network?
No, it's not a bottleneck. It goes like concurrently, if I would say like that. So we are publishing this information on the Bitcoin, and we don't need to stop something, because we are taking this hash of a block, starting this process of publishing, and we are going next. It's no problem. We don't need to wait something.
Okay, so great. And the last question is, does anchoring work with other networks, multiple networks?
Yeah, it's not a problem to provide anchoring mechanism for Ethereum, for example. We already have anchoring for Emmercoin, also cryptocurrency. So it depends only on purposes and business needs. Now we need only anchoring for Bitcoin. Also, this is one of the most popular cryptocurrencies in the world. So, yeah.
Dmitry Apanasenko, tech lead from Exonum, thank you very much.
Thank you. Thanks for your attention.